Okay, I will implement a linked list in Typescript, and I will try to make it as simple as possible. So to start, I will create a class that represents each node inside the linked list. So I'll call it my node, and it will accept a generic type. I will call it T. So it has two properties. The first one is next of the same type, my node, and accepts the same generic type, and data accepts the generic type. So yeah, and I will have a constructor. It will accept data conditionally of the same generic type and just assign it. So if the user did not give us data, it will be undefined, which is good. And now the way that we create nodes, it's by another class. We will call it a linked list. So class linked list, it will accept a generic type. So here the creation of the nodes will be here, and this class also responsible of linking these nodes together inside the same linked list. So the first node will be called head, and head, it has a property called next, will point to the next object, and so on. So first thing we will have is the head. We'll make it private head of type my node generic type, and I'll have a size number, and I'll have constructor that just initializes the size 0. Okay, now the first method I will create is append. It won't return anything, and it will accept data of type T. So this is a generic linked list. It's not just numbers or anything. It can accept anything, objects, and I will show you when we reach the delete, when we reach the delete function, how we can handle objects by passing a callback, but I will get to it eventually. So first thing in the append method, I need to check if we don't have value inside the head, which means the linked list is empty. So just create new head. So if not, this dot head, which means if we don't have a head, so this dot head equal new my node, accepts the same generic type with the data, and this dot size, increase it, and just return. And now if we have a head, I need to loop through all the linked list elements, and when I reach an element that does not reference another node in his on it next property, I will insert it there. So let current of type my node equal this dot head, and while the current dot next, while the current dot next, you can say not equal to undefined, but if you just put it like this, it's the same thing, since undefined is a false value and will break us out of the loop. Since we reach at the moment we reach a dot next property that holds undefined, which means this object does not reference another object. So current equal current dot next. So this is how we loop through the linked list. So after we break out of the loop, current dot next will be undefined, so we need to append the new element there, or the new object. So new my node data, and this dot size plus plus. So this is it. This is the append function, and we can test it. So const list equal new linked list of type any. I won't bother, but you can create an interface or a class and pass it here. And first thing, I will put list.append 1, and let me output the list. So as you can see, we have the size is 1, and we have a head which points to an instance of my node, and it holds a data of 1. So if we did it again, for example 2, so then the head points to an object, the data of it is 1, and the next property of that object, the head, points to another object that holds the data 2. And let's append another thing, so 4. So next as well here is an object that points to another object that holds the for property. Yeah, but I think you got it. It's easy. Okay, the second method we will do is the prepend. So I want to insert an element in the same place of the head, which makes the head the second element, and the new head is the first element, the original. The new head will be the head, the past head, and the old head will become the next value. Prepend. It won't return anything, so void, and it will accept data of type T, and const new head equal of I will make it of type, or just, yeah, so my node of the generic type equal new my node of data, so pass the data to it. And what I will do, I will make, so this new head, the next property of it, I will make it point to the original head. So new head dot next this dot head, so it points to the original head, and the this dot head will become the new head. So like I'm making this head as the second element in the linked list. That's it. And just this dot size plus plus. We can test it. So let's dot append 1 list. And by the way, you can put objects since it's generic. So name what my name, and list dot. So we have, okay, let me just list dot append 1. So we have two nodes inside the linked list. I want to add a new head, so prepend with 0 and list. So the head now holds the data 0 and points, so let me remove this, and points to the, so the example now I am appending 1, then prepending the value 0, so the head is now holds value 0 and points to the original previous head, which is good. This is the behavior we want. Okay, so now I think it's time to implement the, I'm not sure what they usually call it, but I will call it put. So this accepts data of type T and a position. I'll call it pos of type number, and it won't return anything. It will allow you to insert an element in a specific position in the linked list. So first thing I will do, I will create, I will check if this dot size is less than I, is less than position. So you are trying to insert a new element in a point that we don't have it in the linked list. You can implement something like this. You can loop at this position and just keep inserting empty objects in the list. You can do that, but I won't, so I will just throw error. And second thing we will check if we don't have a head, so if not this head, so which means if we don't have a head, I will create the head. So this dot head equal new my node data and return. And one of the if statement as well. I need to check if the position is 0, which means you are trying to put an element at the head position. So what I will use the prepend. I will pass the data to it and just return. I think you can do if else, so don't pass these multiple times. Okay, and now we need to do our loop. So like this. So the current will be equal to the head, and while current not equal to undefined, or like this, while current. If I want to check the position by defining a variable called I. I will assign it to 1, since here we are checking if the position is 0. So I will start by checking if1. So if I equal to position, this is where I should insert the new element. So node, I will create a new variable called node. I will assign it to a new object with the data. And what I will do, I will break the link between the current node and the next node by linking the current node dot next to the node, and the node dot next to the next of the current node. So node dot next will be the current dot next, and the current dot next will be equal to node, and then break. Just that's it. And to make the loop moves, I'm not stuck in infinite loop. So current dot next, and I need to increase the I. So this is how you create to put an element inside a specific node. And I'm here not checking about the current dot next because I need to. I think what no. Next, yeah, like that. Sorry. So let's just try it. So let's put this object, empty object, at position 0, and this should be, yeah, it's only including the head. And at position 1, nothing, because we are throwing an error since the position is more than, what is the condition? Yeah, it's bigger than the size. So okay, now let's try this dot prepend 0, no 1. Okay, now let's try list dot put 9 at position 1. So yeah, we need to check the next here. So what I'm saying, first thing, I'm not prepending or appending anything. I'm just saying put this object in position 0, which means make it as the head, since our if statement handles that this case. And I'm prepending 1, which makes this element as the head, and I'm putting the value 9 in the position 1, which is the next element. Yeah, which is everything is correct. Okay. Now we need a function that deletes. So I'll call it delete. It won't do anything. But since we are accepting any kind of data, not only integers or strings, it can accept objects as well, or arrays. That doesn't matter. So to filter based on the value we need to delete, I will pass a callback. So the user of this class will have the ability to do this. So it's a callback that returns a boolean, and I will give you the data. I think I need just to. I think every method inside this class will just have a couple of checks before executing anything. So if we don't have a head here, just return. You can't delete from an empty list. And another thing I will check. So if you take a look at this loop for example here, we are not passing the first element, which is the head. That's why we are checking these. I'm checking if the position is 0. Okay, you are want to put it inside the head, because here we are starting from the next element to the head. The same thing applies here. So I will create the while loop will be something like this. 1 second, just. So while current dot next. So while we're having a next element, just keep calling the callback for it. But we won't, like this, we won't access the head. So to do this, just before the while loop, so if our callback and pass it this dot head dot data, if that returns a true, which means you want to delete the head based on its data. So this dot head equal this dot head dot next, and this dot size minus minus. And I think I need to increase the size here. Yeah. So this dot size plus. Anyway, so and here I need them to return. So if you want to delete the head, I'll assign it to the next element in the node, in the linked list. If that is undefined, which means we're only having one element is the head and will be equal to undefined. Yeah, and now we will loop through each element inside the linked list. So what I will do, I will just put an if statement. Basically, I will pass the value to the callback like this, but it will be current.next.data. And if that returns true, I will enter this body of the if statement. So current.next equal current.next. So I'm not deleting everything physically. I'm just making a reference from the current element dot next. So when you the next property will reference the next dot next. So reference will skip an element. That's it. I'm not deleting it. I'm just skipping it on the chain, which will be deleted. I think if I give it like a thought, I think the garbage collector will notice this thing and remove that object from memory, because I'm not deleting it. I'm just passing. I'm not referencing it anymore. But anyway, so this, and now this dot size, I will subtract it by 1 and just return. And as usual, to make the loop moves, so current equal current.next. I think that's it for the delete method. And yeah, so let's try it. So dot delete, you need to pass a callback that accepts data of type any, for example, and it needs to return a boolean. So if data equal 9, then delete. And now list will be okay. As you can see, we don't have the node that holds the data 9. And let's start with the 1. We have it. I think I made a mistake. Oh no, we don't have it. So let me turn false. So this object, this linked list, holds the 3 nodes. The first one of data 1, second one of data 9. So let me delete the one that holds the data 9. So if data 3 equals to 9, we see that the first element holds the data 1 and the second element is the empty object. Let's delete the 1. The first element holds the 9. Here we are saying that deletes the first element, which is the head. Which I think won't reach this while loop, since you see these while dots. This Quaka just tells us that this function here gets executed, but this value here, this if statement returns false, so the orange value, and this one returns true, green value, and Quaka executed these lines and did not reach here from this delete statement, since we are deleting the head element, which is good. And I think another thing you can do is delete by position. I don't want to make the video longer because it looks very similar to this one, but you need to check for the position. So if the position is equal to I, since you are looping and increasing a variable called I, just the current.next will be equal to current.next.next. So you are just skipping an element by position. I think that's it. That's like a basic implementation, and I think it does the job. And yeah, I think I am repeating myself in a lot of places, like the while loops. Maybe you can create a function and pass it a callback, so it always loops through the linked list, and this is part of a callback that you pass. You can do this, but this is the basic idea behind it. And I think a good place to practice these, which I was doing this, so I'll just show you. I will put the link in the description. So here in the HackerRank, they have a set of problems about linked list. Basically, all the methods that I implemented are, each one of them is a question here. So print is easy. So insert a node at the tail of the linked list. This is easy one. Insert, I don't think I implemented this, but no, sorry. The append function does this. So this is the answer for this question. It's just the append function. And insert a node at the head of the linked list. This is the prepend function. Insert a node into a specific position in the linked list. This is the put function. Delete node. This is our delete, but without the callback. Print in reverse. This is also an easy one. You can just store them inside an array, the values, reverse it, log it. Reverse a linked list. This is, you need 3 variables, current, previous, and next. You can reverse it like that without using a stack. Most people say use a stack, but you don't need to do that. Reverse linked list. But anyway, I will start. I already started solving these. I'm almost finished, and I will put videos about them so I can understand the list more. And I will do for each one of these. I will just implement it, solve question for it, and upload them. Anyway, thank you.